Good day. Today we are going to be continuing on with our Raspberry Pi project. Today we're going to be adding a DHT11 sensor to our Raspberry Pi and get programming in Python. So with that being said, let's get to it. So I've got my Raspberry Pi all wired up here. You can see my DHT11 sensor here. All I'm doing here is putting that, so it'll be the middle pin is my output. So that's going to GPIO 17. And then I have my power going from the left here, that's the positive side, going to my 3.3 volt rail here. And then I have the right hand side here going to my ground rail at the back here, which is then bringing in over on the other side here. As you can see, there's that GPIO 17 that I was talking about, and that's going in to the back right here, right in the middle there. All we're going to do is, and then, this power is going to the rail, which is then going down here, and then onto my 3.3 volt. Once again, the ground here, going to the ground rail, then in turn is coming down here, and then coming into my ground here. So I'll just leave that there for a second. So the first thing I want to do here is I want to be able to just double check my code here. So I'm just going to bring up VNC Viewer here, and we're just going to take a look at our code that we did last time for that LED there. So that LED is still connected there. So I'm just going to go ahead, I'm going to run that code there, and we will see if anything happens. Oops, I guess that I have to run it like this. There we go. So what we're going to do here is we're just going to test this code again to make sure that we are working here. So I'm just going to right click it here. You can use Control-Shift F10 if you want to run it as well. And there we go, we have our LED running. So now we're going to create a new document within this, and we're going to do just the DHT for right at the moment here. And then we're going to incorporate that LED in there somehow, and we'll figure that out as we go. This time we're going to actually use the library from Adafruit for the DHT11 sensor, and an example I found that is so basic, it'll get us up and running in no time here. So let's go ahead and do that. I will post in the description below a link to the code as well as posting it on the GitHub as well, so you guys can have the link to the author's post on it. So the first thing we want to do is open a new document here. So I'm just going to go File, New, and we want Python file, and we're going to name this one DHT11, and then we're going to hit Enter. Now here we go. So now that we have this, the first thing we need to actually do to be able to control this and program for it is we have to install the Adafruit DHT pip package. So to do that, all we're going to do is click on Terminal in the bottom here, because, you know, it's working now, so that's a good thing. So all I'm going to type is sudo pip3 install, and that'll be Adafruit _ DHT, and then I'm going to go ahead and hit Enter. This may take a moment, so you just have to bear with it. We'll let that do its thing here. So it's going to download and install that pip package. Now you can download these packages from your terminal if you are using another IDE as well. If I went and opened my terminal here and I did the same command, sudo pip3 install Adafruit DHT, hit Enter, we should have it so that way all of it is good to go. It should be like it's up to date, it's already satisfied. So we can do it from terminal here. We don't need to run it through PyCharm here. We can just directly run it through here that's the only perk of having PyCharm, is you're able to run everything through it here. So let's go ahead and start the code here. So the first thing we want to do is, I will post at the top here, so I'm going to type as a little reminder up here to insert URL for original code script. So I will insert that there. So all we're going to do is we're going to go helps if I can spell again, import, and then we want to import that Adafruit DHT, hit enter, FRUIT underscore, yeah, okay, and then we want to import, we're going to import time, and then we are going to go DHT underscore sensor, and that will equal Adafruit DHT, so we can hit tab there, and then dot DHT11, hit enter there, and we're just gonna, that's just allowing, so the idea here is that DHT sensor is what we're going to be referencing when we're pulling the information from the DHT11 from the Adafruit library. And now we're just going to set the DHT pin to equal 17. So this is referencing the GPIO pin, the one that I have it plugged into. Or this is going to be pin 11 on your Raspberry Pi. So you can go ahead and plug it in there, and that'll be that. So like I said, I will not be teaching you everything about Python programming, but giving you the basis that even taking someone else's code, you can learn a lot of what's going on and how to properly start to write your own code. And by using these small examples, it's going to lead you up to bigger and bigger projects. So that's what we're kind of doing here to get you used to even copying someone else's work to get your projects to work. With that being said, you can always alter it to work for you as well in more ways, or you could add multiple projects into one project, and that's what we're going to be doing today with the LED there. And then next week we'll maybe incorporate one more thing, and then we'll go on to something else, and we'll build a bigger picture of a big system we can build all in one. Well, true, humidity temperature equals, this will be Adafruit DHT dot read, and then DHT underscore sensor, and DHT underscore pin. Alright, and then we'll go ahead, hit enter. Now we're going to do the if statement. So if the humidity is not none and temperature is not none, we want to print temp equals curly bracket 0.0.1 F. I can get that curly bracket back in there, and then C, then we'll go space humidity equals 10.1 F curly bracket percent, and then we'll go to the other side of that guy, and we'll go dot format temperature humidity, and just like that we got our double brackets there. And then okay, so now we're going to do our else statement here, and helps if I spell that right. We're going to print sensor failure check wiring. So I guarantee you are going to get some errors. These DHT11 sensors are not, I don't know, maybe it's something with the timing, but I haven't found a good way to actually allow it to produce no errors on this one here. I do have other ones. I should probably test them out sometime and see if any of them work better. And then we're just going to go time sleep. And then how many seconds? We'll do 5 seconds. And then we'll go there, and there we go. That is our program. Now we should be able to run this, and we should actually see something happen. So let's go run DHT. Interpreter settings. We're going to add Adafruit DHT. Okay, let's do that. Okay, let's install that package. Okay. Let's see if that actually shows up. DHT successfully installed. There we go. So it really wasn't showing up, which didn't happen on my other installation. So yeah, unfortunately it looks like I messed around for a while there, and that was all I needed to do. And now we have it here, and now we should have it under our somewhere here. There we go. We have it finally hiding under here. So now let's go ahead, let's clear this guy, and then we'll go ahead and run the program now. And line 12 of the module, temperature. Now we'll just continue on until we've got everything working. Temperature is not defined. Well, looks like I can learn how to spell. Okay, maybe now. There we go. And so now we have our code running, we are collecting data, and nothing fun is happening on the Raspberry Pi. So the next step I want to do is I want to create a new file, which I've already done because I forgot to hit record on the computer again. So I just created a new file. All I did was went File, New, and then I went to Python File, entered my name, my DHT11 with LED status, and then clicked Enter, or hit Enter. And then all I did was I copied all this code here, and then I imported it into, or just copied and pasted it into this one here. So now this code here is completely stopped. What we're going to do is we're going to add some stuff to this file to get that LED blinking. Okay, so I'm just going to bring up my window here so you can see the LED there, and we can see everything all together here. And now we're just going to go up top in our code here. What we'll do is we will now import the RPi. This is what we did last time. .gpio as GPIO, and then we're going to go down here. Get down here with these guys, and then we're going to do that GPIO dot set mode, and then it'll be the GPIO dot BCM. So now we need to set our output pin of our sensor. So we have the DHT pin equaling 17. So we need to set our pin for the GPIO. So all I'm going to do is hit enter again here, and you know what, let's do the GPIO dot set warnings, and we'll set that to false. And we'll go ahead and we will add that GPIO dot setup, and we're going to put this to pin 18 like it was last time, and then we're going to put comma GPIO dot out. That LED should turn on if we add something to our statement here. So all we're going to do for that is a quick, simple one here. So since we were getting some errors there, I want to see that we are getting errors. And when we get an error, that it turns that LED on. All I'm going to do is put GPIO dot output, and then we're going to set that to 18, and then GPIO dot high, and then close it, and then we're going to go time dot sleep, and we'll do 5 seconds on that as well, and then we will set it to GPIO dot output, and then 18, then GPIO dot low, and that should turn it off. Then we'll sit for 5 seconds, and then it should print again. So let's go ahead and have a look at that now. So I'm going to go ahead, I'm going to go play, run that guy, and we should see something here. I wonder if that guy here shouldn't be more like right here. Control Shift F10, there we go. Okay, so there was a little error in my code there, but we figured it out. So now every time that that sensor fails, as you can see there, it's going to start to flash that. The next thing I would want to do is add another LED on here, or this LED I should say. And all I'm going to do for this one is I want it to kind of like flash really quickly. And then that way I know it's logging actual data. And this way, if it's on and I had like an SD card or something like that logging all that data, I would be able to have, you know, a visual that data is being done or errors are being produced on the board. This would be my, you know, initial let me know. There's other ways we could do this, but this is just for this as a test of kind of putting two items together here. So the next thing I would want to do is just like we did down here. Okay, so I'm just going to copy this here, and then I'll just paste that into place here. And then I think I'll do this here, and then go like this. And you can do this as many times as you want, but I think 2 times, 2 flashes quickly will be a good starting point here. So the first thing I'm going to do is I'm going to put that down to a half a second. So I'm just adding a decimal point there. And then all I'm going to do is stop and rerun. Okay, let's have a look here and see what happens if we've actually got it. Wiring failure. There we go. Alright, let's stop that. Let's replay that. There we go. We got the double flashes. And then we should kick back in. Double flash. Maybe, hopefully. Nope, another wiring error. Now, is it a wiring error or is it because I have something set too long? So I'm going to go down here. Let's set this for 2 seconds, and then this for 2 seconds. That should give us 4 seconds before we check again. Okay, so that seems to be working a little bit better. I'm getting a little bit better results here. Yeah, so that's that guy. Okay, so that's it for me for today. Unfortunately, it didn't go as smoothly as I would have liked, but in the end, we got that LED to blink. We got the DHT11 sensor working, so I'm happy with that for today. Next week we'll add something else to it and see what else we can do, but this was just a good example of how to use someone's existing library in a project and then manipulate it a little bit so that way you can try out your coding abilities, taking simple projects, making them more and more complex over time. This is a starting point where I think you can start to read and understand. Once again, if you go to those interpreter settings, you're going to be able to make sure your library is there. If you're getting an error, if you used pip to install your library or your module and it's not working, then chances are you have to go in there and add it in. Unfortunately, on this Raspberry Pi, is the first time I've seen that happen. I've run the exact same stuff on another Raspberry Pi and it worked without an issue. So we're just going to go with that for today. So thanks for watching, everyone. You have a wonderful day, a wonderful week, and we'll see you next time. Take care, eh?